Maybe I should have discussed this before discussing sea level, but it doesn't matter. We are learning a little bit this way and a little bit that way, but we keep adding to our knowledge. What is this? Now you're asking, if sea level is not rising everywhere and is sinking some, is reducing, decreasing somewhere, then is global warming happening everywhere? Global warming is warming when you average over all the world, which we saw before. If we take a baseline of something like 1960 to 1990 or the 20th century, you can do it in many ways. As we said, the temperatures were cooler than the baseline before about 1930, and after the Second World War it jumped around a little bit, warmer, cooler, and then by the 1980s it started warming, and year after year it may not warm because you have some heat going into the ocean, some going to melt the glaciers, as we said, some evaporating the oceans. So you have year to year changes. But what did we say before? We said when we do climate, so we average the weather out year after year and we look at 10-year average. Are the current 10 years warmer than the past 10 years? And the answer is of course. But let's first open up the map and see where it is warming and where it is not warming so much. So the scale of the warming is given here, but here I can just tell you that warming over the past 30 years is much faster than the long-term trend. How do you know that? You take all the temperatures we have from 1901 to 2023 and you can see that there is some warming here. Maybe it's faster than the warming here. There is some warming here and there is no warming here. Maybe there is less warming here, and so on, right? If you come closer, so this is the warming trend. You can think of this as warming per degree centigrade per year or degree Fahrenheit per decade that is being shown here. If you look at the same trend map or the rate of warming map for a shorter period like 1994 to 2023, so now you are looking at temperature change over only these years, and now you look at degree Fahrenheit per decade and you compare to this one. Temperatures are warming much faster per decade. Here it was barely half a degree per decade or less. Here it is about 1 degree per decade over the Arctic Ocean, and there is actually a cooling happening here, and there is less warming or maybe even cooling happening over parts of India and maybe here in the Japan Sea, South, East Sea, whatever. There is cooling happening here in the Eastern Pacific Ocean around the Galapagos and so on, and some here, etc., which again just tells you that when you trap more thermal energy from going to space and warm the planet, the winds are still there and the winds are moving around. The heat that you are trapping, some is going into the ocean in different parts, and that creates temperature warming that is not even everywhere. It's like having a big pan on the stove and the flame is very small, and where the flame is you may get more warming, but as the warmth distributes it may get very uneven. Okay, so Earth is very big and we are definitely trapping more energy because we know that it's getting warmer and warmer, and we know that winds are there, winds change, evaporation changes, and the thermohaline circulation that we talked about in the previous section also changes. So the amount of heat being moved by the oceans from the low latitudes to the high latitudes. Remember, when we say energy has to be moved from the low latitudes to high latitudes, ocean is doing some work and the atmosphere is doing some work. So the ocean transport of heat and the atmospheric transport of heat are different, and they can produce temperature patterns. But as we saw before, if we do decades of warming. We can see we were cooler before the 1930s, and then we started warming, and each decade now is warmer than the previous decade. So this is serious evidence of energy being trapped and energy being distributed across the planet. What does this mean? Means the Arctic is warmer. Why is that? Now you have to think about your great scientific knowledge you accumulated. If you start warming the Arctic, what happens? Remember, Arctic is full of ice and snow, and the Greenland has glaciers. What happens to the glacier? It begins to melt, sea ice begins to melt, snow on land begins to melt, which means the albedo, reflection of the sunlight, reduces because the ice and glaciers and snow have a higher albedo than the water or the land below it, which means you're trapping more of the sun's radiation and reflecting less of it, which means you warm faster, which means you melt more glacier, more snow, more ice, and soon you are warming faster and faster on the Arctic compared to other places where you don't have the ice albedo feedback. You have similar feedbacks over deserts, which I won't discuss here, but just remember it, and when you grow up you can follow it up, or if you're old enough you can look at my other podcasts. But you now know ice albedo feedback is causing something called Arctic amplification or polar amplification, which means the Arctic is warming faster than pretty much everywhere else on the planet, especially compared to regions that are actually cooling, like here and here and here and here. Okay, so this is very important. You now remember a keyword: Arctic amplification or polar amplification. There is an ocean and land here which behaves very differently, so you don't have a clear ice albedo feedback here, because as we said, as the ocean gets warmer, atmosphere gets warmer, and it puts more snow on some places and glaciers grow, and you can see some negative, some positive, some positive, some negative, and so on. So this is a complicated place. That's all you have to remember. Okay, so let's move on and read a bit about what is happening. The Arctic Ocean is warmer. Ice melts, causing seas to rise, plus warm drops of water expand. They take up more space. With those effects, global sea levels have gone up about 8 inches over the past 100 years when we average over the whole globe. During storms and hurricanes, heavy winds cause a storm surge, a sudden powerful push of water from the ocean onto land. With higher waters, the surge of water is greater. Water covers more land, doing more damage as sea level rises. Hurricane Sandy that we looked at had a record storm surge 13 feet in New York City. In regions near coasts, rising water levels mean higher daily tides, because tides are naturally happening, but now they are working on a higher sea level, so they bring more water and they cause more flooding as well. So you can see here houses getting storm surges that are higher than the houses and can blow off the roofs here and inundate the lower floors, and maybe even knock down the house or erode the coast here and knock the house into the ocean, and so on and so forth. Okay, so we will stop here, but just remember, the warming is not uniform, the sea level rise is not uniform, but global mean averages are going up, and that's important because we are trapping more energy, and we can easily say we continue to trap more energy as long as global mean temperatures go up and global mean sea levels go up. And this is something of concern, and it is also of great concern to worry about. Will sea level rise along the coast of Mumbai? Do I have to worry about my apartment? Will cyclones begin to come more and more into Mumbai and bring more and more storm surge? Or whether Florida, Miami will begin to go underwater? Whether Manhattan, New York City will begin to get inundated more and more and more, and so on and so forth. So these are not trivial matters. So even though understanding may be incomplete, we must pay attention and do something about it, right? So this is what is on you, because you are young and you will grow up and see these things happening, and the future is yours and you are the future, so you need to worry about these. At least understand and make educated judgments about the risk and what you can do about the risk, and whether you want to grow up and become a great engineer, a doctor, a social scientist, a politician, and so on, who will make strong climate decisions and bring about climate action and green technology and renewable energy and so on and so forth. Okay, see you in the next podcast to talk about a little bit how the global warming is actually happening, how much is coming from greenhouse gases and how much may be coming from the volcanoes and so on and so forth, just to complete our knowledge. We are talking about extreme weather, so you already see that there are 2 time scales of extreme weather. The sea level is rising slowly, but strong cyclone can come quickly and extreme rainfall can fall quickly, heat wave can come quickly, and snowstorm can come quickly. So there are chronic changes, so temperature warming slowly and sea level rising slowly, and there are acute issues like increasing cyclones and heat waves and extreme rainfall. You don't have to worry about it if you don't know, but if you're old enough, then you can follow up on acute and chronic impacts of climate change. Okay?